Hello everyone, this is the Logarithms lesson part 2. And from yesterday, we have already done the first proving for the multiplication law. And now I'm going to do the division law and the power law, the proving of them. Well, firstly, let's prove the division law. So log ax over y equals log ax minus log ay. Well, we used the same method as we did yesterday, which is we change x into a to the power of log ax and y into a to the power of log ay, which is the lemma I did yesterday. And if you are not familiar with these two, you can go back to yesterday's video and check again. So now let's substitute, which is the left hand side equals to log a to the power of log ax over a to the power of log ay. And we know this equals log a to the power of log ax minus log ay. And we know this will equal to log to the power, which is log ax minus log ay. From the lemma we have also did in yesterday. And this equals the right hand side. Okay, so this is the proof for the division law. It's not that difficult, right? Okay, let's do the power law. Actually, it's the same thing. We just change log the x into a log ax. We do it again, which is a log ax bracket m equals left hand side equals that, and we times m in, which is log a to the power of m times log ax, and this equals m log ax, which is equal to right hand side. And the proving is also done, so you can check this. Well, if you don't have any questions, we can move on to some. I think we should try more harder questions. And before we try harder questions, let's just start from the medium level questions, which I think it's acceptable actually, like this question. Well, it looks quite complicated, right? It's not that simple like log 2(3) plus log 2(5) or something. There are some like squares inside, and there are some minus some equations. Okay, so what should we do first? Well, firstly, there is a square here, and there's also a square here, but this square is inside. So here is log 2x bracket square, and the easiest thing I think we should do is to change this x squared into x form, so we can have the same x. And so how do we change that? We can use the power law here, which is x to the power of something. We can bring the power into the front. So here we can move this power of 2 into the front as well. So which becomes 4 bracket log 2x bracket square minus 2 times 2 log 2x equals 3, which is 4 bracket log 2x bracket square minus 4 log 2x minus 3 equals 0. And what do you think about that? Do you feel you have seen this before, or like it's very familiar to you? Yeah, that's the quadratic equation, right? Let's just write y equals log 2x, and this will becomes 4y squared minus 4y minus 3 equals 0. And for that, we can solve it by using cross multiple, and which is 2y plus 1 bracket 2y minus 3 equals 0. And you can get y equals negative a half and 3 over 2. So now we have log 2x equals negative a half. And we know that x is equal to the power of negative half, which is square root 2 over 1 over square root 2, which is square root 2 over 2. And for the other one, which is log 2x equals 3 over 2, we can get that x is equal to 2 to the power of 3 over 2, which is 2 times 2, which is 2 square root 2. So I think we have solved this problem. And that is a medium level question. I don't think I did something wrong, right? Yeah, I think so. Okay, so let's move on to a harder question. Well, it's actually it's not that hard, but it's still harder than the questions we have just did. So it's a simultaneous equation, and it involves some log and something. Well, let's do this, right? So how do we solve normal simultaneous equations? Our aim is try to cancel y, so we can get an equation that only contains x, right? That is called elimination, right? Yeah, elimination. But here there are log inside, so what should we do? We can't solve it in usual ways, right? So we should change it into a form that we are very familiar with. So how do we change? Well, let's use the power law here. The power law. Well, actually not the power law. It's the lemma. It's a lemma that it's actually, let's just do it, because we know log 4x plus y plus 9 bracket equals 0. And if this is correct, then I assume 4 to the power of log 4 x plus y plus 9 is equal to 4 to the power of 0, right? That is also correct. This means, well, we have learned that this one is equal to x plus y plus 9, which means, and this one is equal to 1, which means x plus y plus 9 equals to 1, and x plus y equals to negative 8. That looks more comfortable, right? Yeah, and also we do the same thing for the first equation, but this there we need something else. So firstly, let's subtract that. Equals 0. And now we need to use the power law, which is m log ax is equal to log ax to the power of m. Now because we can move the power down, which means we can also move the power up, which means this becomes log 4x minus y minus log 4x squared equals 0. Now let's use the division law, which is log ax minus log ay equals log ax over y, which means this becomes log 4 bracket x minus 1 y over x squared equals 0. Now it is now the form is similar to this form. So we do the same thing we have just did here. We add a 4 to the power of log 4 bracket x minus y over x squared equals 4 to the power of 0. And that equals 1. That equals this number, which is x minus 1 over x squared. And so we get x minus y over x squared equals 1. And which is x minus y equals x squared. So now we have two equations. One is from here, which is x plus y equals negative 8, and x minus y equals x squared. Well, this type of equation we have learned in AS level, which is we do substitution. Let's substitute y. Let's substitute y, will be easier, which is y equals negative 8 minus x, and x minus negative 8 minus x equals x squared. X plus 8 plus x equals x squared, which is x squared minus 2x minus 8 equals 0. And this will be x plus 2, x minus 4 equals 0. Then x is equal to negative 2 or 4. And which means y is equal to negative 6 and negative 12. 12. Yes, it is. Okay, so which means we get the x and y value. And we solve this problem. See, it takes like 1 page. Yeah. And that is all of today. And tomorrow I'm going to teach you how to do inequalities. And let's start the value of ln, which is the ln. And these are all in your about page 40 in your textbook, and you can find some more questions in it. Thank you for watching and see you tomorrow.